Okay, so the next thing that I wanted to do was to change the colors according to a certain type of color blindness. And I found this JavaScript-based project that somebody had written, and in particular, they had identified the various color matrix um, color matrices to convert the individual colors according to a certain type of color blindness. And so I ended up just grabbing this part at least, and put it in my code. And I'll show that in just a second. But the result is going to be this. So this is the original image. And at the moment, it's basically what it's normal. There's no color transformation. And you can pick different types of color blindness. So you can choose the protanopia, and it will kind of merge the reds and the greens. And I can still see a 6 here ever so slightly, so I don't know if colorblind people can't see this color at all, or even can't even see the shape at all, but you can pick different color blindness types, and it changes all of that accordingly. So the way that I did this in the code was the canvas that is responsible for drawing the images gets paint commands. So whenever I move the window like this here, it's calling the canvas paint method to redraw the image. And I suppose I don't really need to do this inside the get draw method that gets called by paint. But well, that's where I stuck it for now. And so I have an original image taken from the file that I loaded in question. And the other one, the image, which I should probably rename to something else, is the transformed image. So the way that I set this up, I created a transformers package, and inside that transformers package are several methods and interfaces. So the first interface is the color transformer I. So it's going to be an interface, and it expects to take a source color. This should be color, not pixel, and to transform it, outputting a different one. I've got two implementations of that interface. The first is basically a no operation, and all it does is it takes the source color and returns it unmodified. This would be useful if you want to add a color transformation in a chain of, and it's going to be tied kind of to this one here, but I'll get to that in a second. And otherwise, this other one, color matrix transformer, will expect a 3 by 3 dimensional array of doubles. And it's based on this type of transformation matrix. And so the way this works is the red output has 100% of the red input, 0% of the blue input, 0% of the green, and 0% of the blue. Green has 0% of the green of the red, 100% of the green, 0% of the blue, and blue has 0 of the red, 0 of the green, and 100% of the blue. Red, green, blue. And for this one, it's these percentages. So 56.667% of the red goes to red, 43.333% of the green goes to red, and so on and so forth. So that 3 by 3 matrix is required for this color matrix transformer class. When you instantiate it, you need to provide this. And there's a parameter whether it is expressed as a percent or if you have a different input source that would have a value between 0 and 1. So here, if it's expressed as percent, it just divides each of these values by 100 to make it a value of anywhere between 0 and 1. I've got a few checks in there to ensure, to guarantee that it really is a 3 by 3 matrix. And the transformation is fairly simple. I take the red value and I multiply it by the color red input source, take the green, multiply it by the green input source, multiplier, and do the same for the blue. So now I've got 3 separate colors. Then I just create a new color and I return it. So those are the worker threads, the worker classes that will transform or not transform the color accordingly. I've got a separate class which also implements the color transformer interface, and the purpose of this will become clear in another video later on, where you might want to daisy chain several transformations. And just to give a bit of a preview, the point of this utility is to be able to take this source input, and let's say I want to transform the colors so that somebody who's got achromatopsia type of color blindness can hopefully, maybe, possibly, I don't know if it would be possible to somehow tease out these colors and have them stand out. So the idea would be to take this, transform it dynamically through a series of sliders. So essentially, I would allow somebody to use some controls to slide the individual values. So you would have a, uh, a 3 by 3 matrix with the individual input transformations. That would be the first step. So that would take this and transform it into one particular color. Then take that and then convert that or transform that according to this type of color blindness. And it may be possible to have multiple other transformations in the chain along the way to really muck around with the colors, but that would be the idea. And so the point of having this class would be in, let's say, the canvas where I have the color transformer. This allows me to keep this in class instance, and this multicolor transformer encapsulates a different one, and you can swap out this other one like this at any time to affect the behavior of the transformer over here without having to reinstantiate a new one here. So it would be useful, it could be useful, and I just did that as a preparation for possibly doing something in the future. So this one here just basically encapsulates another one, and this class here will swap out the worker class accordingly as it needs it. And then the last one is the color matrix transformer factory, where I have the list of names. And so basically I created all of this from this, which came from this URL here, this JavaScript file. So these are all of the color matrix transform values represented as percentages. And it will find the appropriate color matrix, instantiate a new class, and return it. So these are the new classes. In my canvas, I created a new multicolor transformer. Further down over here, I can change it. And so, for example, this would be where I could have a color transformer and a color blindness simulator transformer instance. The two of them could be chained together through maybe an external transformer worker class, and it allows me to swap out the behavior in this even though the same class instance is referenced in some other worker. So that was kind of the reason why I did that. I added a menu that will go and get the list of transform names from the factory, populate a menu item, and then for each menu item, when that item is selected, it will set the color transformer in the canvas, and then it will invalidate to repaint and to redraw the image. And then finally, the last thing that I kind of did here, this is a bit of a brute force approach. Unfortunately, I looked through the API and I can't find anything that looks a little bit easier. I could probably go and get the entire raster and deal with it that way. But in this case, I get the original image RGB value, which is expressed as a 32-bit integer, convert that to an instance of a color object. Here I'm taking the values, the R, the G, and the B value, splitting them up into separate values, and then I create a new color class. My color transformer takes a color class input and returns a class instance, and then I convert that back to RGB. And I suppose I could add an RGB integer for the color transformer as well to speed things up. But then I take the RGB, the color, and then I convert it back to RGB, and then I set the output image RGB to that value, and then I continue on as normal. So that would pretty much be what I did in this part. And at this point, I now can simulate with as much accuracy as these color transform matrix values will allow. According to the various types of color blindness. So that's going to be it for this one. Thank you for watching. If you like these videos, I would appreciate you subscribe and give it a like and help the YouTube algorithm, etc. So I'll see you again in another video.